Aha! Some of the problems we might see here. Induced seismicity, specifically in the Calpines area. This is from 2011, but man-made earthquakes. Uh-oh.
A KQED HD production.
72 miles north of San Francisco, a sprawling tangle of power plants, pumps, and pipes work non-stop to mine steam from the ground and convert it into electricity.
The geysers has been producing geothermal power since the 1960s. It produces enough power to power all of San Francisco, about equivalent to one medium-sized nuclear power plant.
At more than 20,000 football fields in size, the geysers is the world's largest geothermal field. But for nearly 50 years, it's been generating more than just clean, renewable energy.
This green line dashed line here is the amount of earthquakes over magnitude 1.5, and you see it has a pretty good correlation with the amount of fluid injected here.
The injected fluid is roughly 20 million gallons of treated wastewater from nearby Santa Rosa and Lake County that are pumped daily into the ground to replenish the steam fields.
The importance of this is it allows us to really say, all right, human activity is causing the activity of the earthquakes.
That's right. Humans can actually cause earthquakes.
The crust of the Earth is essentially in a state of natural tectonic stress that brings it close to the point at which natural earthquakes can occur. And all it takes in most areas is a little extra push, a little extra stress introduced in the right way on pre-existing faults and fractures to cause small earthquakes.
That little extra push happens when humans mine, pump, drill, and dam to generate energy. The oil and natural gas industry, for example, has been generating earthquakes for decades.
In the 1930s and 1940s, near Long Beach, California, although there were a lot of earthquakes, or seismicity as we call it, associated with oil production, the real smoking gun was when you could stop the seismicity by putting water back into the ground to replace the oil. So that's when people say, oh, it's really human activity that's causing this. It's not a coincidence.
The earthquakes are a byproduct of a process called hydrofracture to extract oil and gas. The pressurized fluid opens up the oil and gas-rich rocks, pushing them apart. And as the rocks move, energy is released, generating small earthquakes. Even filling up a reservoir behind a dam too quickly can cause earthquakes, and occasionally to deadly effect.
In putting water behind dams, you cause a greater loading on the earth. And if there happens to be some faults there, pre-existing faults, then you can cause larger earthquakes. For example, in India, at Koyana Dam, there was over a magnitude 6 earthquake that killed over 200 people.
That was in 1967. More recently, some suspect that a dam built in Sichuan, China may have hastened the arrival of a 7.9 earthquake that killed tens of thousands in 2008.
If you happen to go to an active fault, that active fault will naturally produce large earthquakes, and if you perturb it at the right time and in the right place, you might trigger that natural earthquake sooner rather than later.
The risk of a similarly massive earthquake ripping through the Bay Area triggered by geothermal work at the geysers is not likely, according to scientists.
If you look at the San Andreas Fault, it's hundreds of miles long, and we have big earthquakes along that fault. The faults and fractures up at the geysers are very small. They range from maybe tens of meters to hundreds of meters long, maybe a kilometer long. And that's not large enough to support a large earthquake up at the geysers.
Maybe not, but the sheer number of the earthquakes at the geysers is staggering.
This is an animation of about a month's worth of data from a geothermal well at the geysers. There's about 750 events here. The largest one here is about a magnitude 2, but the great majority are less than a magnitude 1 or around a magnitude 1.
Most of the quakes are too tiny for people to even feel, but some can be felt 3 miles away from the geysers in Anderson Springs, keeping some residents up at night quite literally.
We average earthquakes of magnitude 2 or larger about one a day. And of earthquakes that people can be woken up with that will shake the house pretty strongly, that's easily every couple of days.
Hi, Jeff.
So this is not a once in a blue moon thing. This is a constant problem that has really changed people's lives.
As president of the Anderson Springs Community Alliance, Jeff Gosby visits with neighbors to see the toll the earthquakes take on their property and peace of mind.
Look at this.
Wow. So this actually goes not only through the cinder blocks, but into the actual poured foundation.
By the way, there was an earthquake not too long ago that hit, and it woke me up. My heart was pounding, and I didn't get to sleep for the rest of the night because of the adrenaline rush.
According to Gosby, those adrenaline rush-inducing earthquakes are on the rise.
Going back to 1975, up until 2000, above a 5 can't be created here. What if larger earthquakes do happen?
And look at that.
9 miles away, Calpine, the largest company working at the geysers, is expanding operations with a new way to tap the Earth's bounty of heat.
Calpine has started a project called an Enhanced Geothermal System, or EGS project, in the northwest portion of the geysers. We're going to inject water into an area about 11,000 foot depth, and that area is very, very hot. What it will allow us to do is tap heat at the geysers that was previously unavailable.
If enhanced geothermal systems can be developed, all we need to do is to find the hot rock, which is ubiquitous almost everywhere in the western United States.
Geothermal energy generates very little smog or greenhouse gases, and unlike solar or wind, it can produce electricity 24 hours a day. The Department of Energy estimates that enhanced geothermal could generate 10% of the nation's electricity needs. But it's not without challenges. For one thing, in a traditional geothermal field, the steam already exists. But in an enhanced geothermal system, the steam reservoir must be created. Man-made earthquakes are a consequence of microfracturing the hot, dry rock to circulate water through it and pick up the heat.
Just by the nature of fracturing rock, you are creating micro-earthquakes. The approach is to create a lot of very small earthquakes, many of which will not be felt. We're putting additional seismic monitoring in this area to really be able to pinpoint where the fracturing is taking place to effectively generate steam.
Ernie Major from the Lawrence Berkeley National Laboratory is working with Calpine to monitor the seismic activity in real time.
I'm standing next to a seismic monitoring station. It takes the signal from a geophone that picks up the motion of the ground, and that motion of the ground is then transferred into this box.
The incoming data then allows rapid communication of quake activity, not only at the geysers, but at 6 other federally funded enhanced geothermal sites.
Hey Steve, this is Ernie. We've been noticing quite a bit of seismicity, a lot of earthquakes going on at Raft River. Do you see that?
Yeah, I see that there's some earthquakes there, but they're coming from outside of our network.
The engineers can scale back the water injection if the earthquakes are getting too big.
Well, let's keep an eye on it and make sure that things don't get out of hand.
Managing the size of the earthquakes is not only vital to the success of the projects, it's also vital to public acceptance. In 2006, an enhanced geothermal project was shut down after it triggered a 3.2 earthquake in downtown Basel, Switzerland. Motivated by the Basel experience, Ernie Major helped write a set of federal guidelines to help manage the risk of induced seismicity.
You don't want to put it close to a very large fault. You don't want to put it in the middle of a large city. The industry has finally woken up to the fact that induced seismicity is a major issue, and it could be a deal breaker if not dealt with properly.
Calpine is heeding the advice while moving full steam ahead.
We do not believe this enhanced geothermal system will create an increase in felt earthquakes. If you look at the active faults in the area and you look at your injection and production activities, I think it's an appropriate risk in order to capture the benefits of this large renewable energy resource.
And as we work to reduce our reliance on fossil fuels while meeting growing energy demands, the need to strike a balance between risks and benefits grows more urgent.
Any source of energy production, including renewable energy, has its benefits and drawbacks. And the energy mix the United States has in the future will depend on the choices we make regarding how we balance those benefits and drawbacks, whether it's solar energy, wind, nuclear, hydropower, or geothermal.
Whoa, I can do without nuclear. I don't know, maybe I shouldn't say that, but
A KQED HD production.
so once again, let's take a look here at our IRIS earthquake browser information and see for our particular area here. We had one on 9/26. Is there another one up here? 9/23, 26. Let's zoom in a little bit more on it. A little more detail. This is kind of neat too. You can see what it's telling you about how the movements of the plates here pulling apart, huh? And this is transformal right here. See, it's moving along beside each other, and that's where you get the buildup of stress and the earthquake potential. This large subduction zone, this time it's yellow instead of blue. Okay, and you see right here plate boundaries, divergent, transformal, convergent over to the left there, where see my little arrow over here. So look to the left in the margin. Divergent, red, transformal, blue, convergent, yellow, undefined, white. And that's what you've got in here is some of these, like in the valley here, calling that an undefined. There's actually it's a convergence of sorts, and you see the other ones out here, these different faults. Okay, now let's take a look here at this, our Montana region seismicity here. So down by Butte we had a little one there. Is that an earthquake? Let's see. Yeah, 923, magnitude 2.1, 2.2, 26. And so you can see here when you're over that information, you see the little dot bounce and it tells you where it is. So this one 2.2, the 26th. So this one the 27th, also in Yellowstone, 7.2 kilometers in depth, 2.5 on the Richter scale, 17, 19, 50 universal time, and then coordinates. 44.11 latitude, longitude 110.39. Okay. So take a look down here. So not much going on there as far as since the 27th. Seems how we're, it's the 28th today. So that's the advantage of your IRIS earthquake browser. And you can take a 3D view of this here. Kind of cool, huh? So we can take a look and see take our XY axis. There we go, we got it. Now we're looking at it from the top again. Oops, we got to bring the south axis around. Okay, now we're getting back to a better situation there. Here's the earthquakes that we were looking at right here. See what the depths are on those. It's not showing us the depth, is it? Okay. I need to play with that some more to find out how to get this centered right up over that area that I want to look at. So much for the 3D view. You guys can play with that and see what you come up with. And you also have a topographic view that you can look at here. So if we go to a global status here for today, looks like they had 5.1 magnitude in Nicaragua, 2.5 Central California, 3.2 Central California today. 5.1 though down in Nicaragua, that's pretty decent. And that's going to take us into the Pacific Ring of Fire, or the Ring of Fire. We're going to get into that here next week. So also what we find is kind of interesting here is that if we take and look at the satellite image here, we actually see the topographic aspect a little bit better. So that Yellowstone, and you see all the ripples, and we haven't had a chance to really look at the Snake River Rift yet, but Yellowstone, which is the current eruption or the volcanic penetration from the plume in the mantle, the magma plume is coming up through Yellowstone National Park here. And you go on out here on the Snake River Rift, and you can see the salmon into the Snake River Rift. And here's the craters of the moon. If we get out of here into craters of the moon, let's get a little bit bigger, a little closer. Red Bozeman. Okay, there's Yellowstone National Park. This is not quite as nice as Google Earth, but it has better labeling. And we follow that Salmon River Rift on out. I'm looking for Arco. Right there. Craters of the Moon National Monument. And as we get on out here to Jerome, Twin Falls, Snake River Rift. There's a major separation going on there. Very definite crack. When we look at that if you've been through that area. But anyway, this is an older eruption, and what the theory, one of the theories is that the continental crust is moving to the west, and that the magma plume underneath is stationary. And what's kind of interesting is that there has been some activity. See, here's our earthquake right here. Let's see what's going to show up for us. There we go. 27th, 7.2 kilometers deep, 2.5 magnitude. So it wasn't that long ago. And the closer to the surface they are, the more damage they do in general. So that's relatively deep. Not very high on the Richter scale, but we look at this one out here in West Yellowstone. Let's see if it's... That was on the... well... Okay, that's... There we go. She's bouncing for us. 25th. 12.3 kilometers deep. Magnitude 2.5. So anyway, the seismicity in relation to Yellowstone, we've got to look at some of the theories that the different people that have access to the seismological information, because the USGS, the United States Geological has been limiting the information that they've been releasing on these earthquakes. And there's a rift that opened up out here in the Bighorns. Check this out.
Wow.
What do you think?
We'll talk about earth changes. This massive gash forming in the earth, some dubbing it the gash, in Wyoming at the foothills of the Bighorn Mountains. This has caught a lot of attention here recently. In the first images, people were saying, oh my gosh, is this even real? Well, we've got confirmation from other people that have gone out here and checked it out and said, yes, this is real. Not sure exactly what has caused this, but we have some trying to explain it away as being water flowing over top the cap rock that eroded away the bottom part of the earth here. And then everything kind of fell apart. Others saying it looks like it was literally ripped apart. So
some of the theories on this are, and we'll look at this from the air here in just a minute, from aerial or satellite, and this separation or divergence, diverging interaction here, this is the same type of stress pattern that manifested itself before the largest landslide in modern history on Mount St. Helens occurred.
this shot, taken from someone's car right above the ridge as well, looking down onto it, is one of the better shots, showing you how it really does look like it was just ripped. And as far as the water flowing over the cap rock, I'm not so sure about that. Regardless, you would have to say, all right, an event of this magnitude had to register an earthquake or something. Well, of course, if you go looking around Yellowstone on USGS, you get nothing. Ten Sleep sitting right here, just east of the caldera. The only quakes they have on their map for the past 30 days at magnitude 2.5 or greater are situated over here in these two spots. And it's in my belief, after following information on Yellowstone, for some time, that they're not going to release all the information we're looking for anyway. Here's where it sits. Here's where the caldera is, literally right on the outside reaches of the caldera. You have the earth pulling apart. So for what it's worth, wanted to share with you guys here these images, and give a shout out to channels like Mary Greeley that had brought this to my attention. I'll leave links for all that stuff, and if I get more answers, I'll keep you guys posted. But this is one of those events very near a supervolcano that raises a lot of questions. And no doubt it is indeed a very interesting earth change that needs to be answered.
So if we look at this from the view of the continental plate moving west over a stationary plume of magma underneath, and the craters of the moon have a history of previous eruption, and the current eruption is now in Yellowstone, this very well could be preliminary activity indicating where the next plume might come up, that the crust might have moved. It seems like it's a lot of movement, but things have a tendency to be exponential. Sometimes they accelerate. So anyway, it's just something to think about.
This has been Dabu 7. Peace.
Sweet.
Hey you guys, I wanted to do a video on the Bighorn Mountain crack. There's been a lot of speculation about the crack, and there's also been a lot of misinformation about the crack. The crack was discovered on a private property near the foothill of the Bighorn Mountains, and it's a very large crack. It's 750 feet long and about 50 feet wide, so it's a bit more like a canyon as opposed to a crack. And if you look at the pictures, it's quite large. There were a lot of theories about how the crack formed. The most popular one is that there was some type of earthquake in the region that actually tore apart a valley. And a lot of channels were accusing the USGS of hiding their data on the earthquakes that have been happening in the region, specifically earthquakes that are around the Yellowstone caldera, obviously a very volatile region. Does a crack of this size have to be related to an earthquake, or can this be something else? Is the USGS really hiding earthquake data, as I believe they have done in the past? Well, if we look at the information available online, it does not have to be the case that a crack of this size or a crack in the earth is related to an earthquake, and that might actually surprise you. But if you do your research on volcanoes and calderas, you'll actually find that these types of cracks can be related to something called ground deformation. This does not require an earthquake to take place in order to see a crack of this size or even maybe bigger. So what happens is that the volcano or the caldera changes shape, it swells in certain areas, it collapses in other areas, and they actually monitor the ground surrounding the caldera and on top of the caldera in order to tell how much ground deformation is occurring. That gives them an indication of what's happening underneath the ground. So I actually believe that the USGS knows about this crack. I believe it's related to ground deformation, not an earthquake. What's interesting is that the USGS has highly advanced technology in monitoring ground deformation. They have radars that actually let them know where there's been a major shift in the land, like this crack. So again, I'm not saying that the other channels are wrong in believing that it's related to an earthquake. I just am pitching another idea that this might not be related to an earthquake, but is equally as concerning as an earthquake happening in the region, because this level of ground deformation might actually give us an indication of what's happening under the ground, and the fact that there could be a swelling in this caldera that could be very alarming. So I sent an email to the USGS to understand what could possibly be happening in this region, and to my surprise, one of their scientists responded. I asked him about seismic activity and the potential that the Bighorn crack could be related to an earthquake. He said the following: changes in the Bighorn Mountains are very unlikely to have anything to do with the volcano caldera at Yellowstone. They are too far apart. In a non-volcanic area, cracks most usually open up due to slumping, landslides, or gravity. As such, cracks could open up without earthquake seismicity. I'm not familiar with the specific location you're referring to, so I cannot say more. Cracks can occasionally open up due to earthquakes, but usually the earthquakes have to be rather large, M5 or more. I would not expect cracks to open up due to small earthquakes unless they are very, very shallow and somewhat numerous. If an earthquake had caused this large of a crack, it likely would have had to register at M5 or greater, or have been superficial enough to be felt by everybody in the region. To my knowledge, I have yet to find a testimony that an earthquake in the region was felt and could have caused this crack. As far as it being a landslide or slumping in the ground, it seems unusual considering the Bighorn Mountains are just outside the perimeter of the caldera. While the scientist thinks Yellowstone and the crack are unrelated, I think very well that these two could be related and should be investigated.
Yeah, man. You see here a little quick little blab about the how the plume moves.
Let's
under the
suppose that
crust.
you're writing a really important email to a colleague.
And I won't be able to go through this whole thing with you here, but I want you to have access to this on your own time here. I want to take a look at it.
crack.
If you can notice it, notice it.
Right, let them. Right, soon coming down the road.
It's a buffalo jam, mate. It's a buffalo jam.
Here they come. Never been like this before. Are they going to carry on coming or are they going to veer off? Stopped. Blimey, look how many there is. Took my arms in.
Yeah, I'm not so sure about this. Sound like it's getting a little bit hyper here because they like walking on the road. It's easier for them. So I don't think that this is like the animals exiting. But there is some seismological activity of that the one of the wives of one of the rangers that had access to this Yellowstone seismology, some of the stations that we'll look at in the future. Kind of interesting. It indicates magma intrusion, so that there is some activity. And we're also going to take a quick peek here at the continuous eruption of Old Faithful. So back in April 2016, the Yellowstone Old Faithful geyser cam recorded continuous eruptions of the Old Faithful geyser, which is unusual. What's wild is the continuous eruption aspect. Instead of it being Old Faithful, where it erupted roughly every 20 minutes or so, they're having these continuous eruptions over 40, sometimes a 48-hour period. Could be an increase in activity. What do you think? you can take a look at this Old Faithful geyser cam also at your leisure. Old Faithful nonstop. 5 months ago. Old Faithful named such because of its pattern, although it does not go off precise times as people think, but it has been going off continuously. Successive eruptions early morning, 5th of March 2016. So you might want to kind of take a peek at some of these. Then there's Steamboat Geyser. What about that one? Can't forget the rare eruptions of Steamboat Geyser and the largest geyser in the world. That's what I call geothermal energy, man.
Around 11 o'clock I heard a noise. I listened to it for a while and I thought, it's probably just traffic, and I went back to bed, and then I thought, no, I can't sleep anyways, so I'm going to get up and I'm going to drive over there. Sure enough, Steamboat was having a major eruption. I was flooded with excitement, and I decided I needed to go back and get my coworkers. They needed to experience this.
I heard a knocking at my door, and then I woke up and I saw Rosa was there, and so she said, Steamboat Geyser's erupting. I was like, what? And Steamboat Geyser's erupting, you want to go?
It just took me a second to really hit me what she was saying, and at first I actually thought she was joking. And when we got here, it was pretty evident what was going on. We could see the big silhouette from the plume rising in the sky. And so we park the car, and then we run down here, and we get down to the lower platform, and we just start getting to talk. We were having to just get close and yell at each other. And it was almost like a little mini party at that moment. We all started
jumping around, yelling, hugging each other. It was just the three of us. It was
incredible. The sounds and the sights. It was incredible.
Steamboat Geyser is the largest active geyser in the world.
Major eruptions can be up to 380 feet high.
So it's 3 times Old Faithful, the length of a football field, or 30-story buildings.
And it is entirely unpredictable.
Major eruptions have been anywhere from 4 days to 50 years apart.
And this is only the second major eruption we've had since 2005, and the last one prior to last night's was
July 31st, 2013.
So all summer, the thoughts crossed by my mind, like, man, that would really just make my summer if we had a major steamboat eruption. I've been explaining to visitors how unlikely it is that they'll see a major eruption. Finally, we actually got one, and it's an experience unlike any other that I've witnessed.
Spectacular.
It's amazing. Once in a lifetime.
My name is Rosa Prosser.
My name is Mike Scaife.
I'm Curtis Aiken. I'm a resource education ranger at Norris Geyser Basin. And I've been here for 9 summers.
And this is my first summer working in Yellowstone.
It's my second season here in the Geyser Basin.
Sweet, huh? This is a good one right here. you got to stand back. Man, I'm not so sure I'd want to get up anywhere near it if the ground's rumbling. There you have it. Whoa. Sucked me in on that one, huh? So perhaps the signals are there. We just have to keep our eyes open. But I think it's important that you have a supply of water and some rations. If something does go off, you don't want to be stuck with, because it could be a thing where you didn't have power and you might not have. So you should have a little supply of water and and some food. And be ready to hunker, maybe, huh? Anyway, if you were here for St. Helens, Missoula was down for 3 days. Didn't lose power, and we had gravity flow water, at least where I was at in the Rattlesnake. So, but it was pretty scary. You couldn't see across the street. In the ash, you couldn't drive your vehicles because the ash clogged up the filters, and eventually then got in and burned up the bearings in your car. So, if this one went off, we could have an ash issue here, perhaps. If it went off catastrophic, we'd probably be incinerated in the compression ring, the toroidal ring. You know, the ring that comes out around an atomic bomb. Well, the compression ring around Yellowstone in a catastrophic scenario would pretty much incinerate everything for about 200 miles. So, yeah, man, kind of like Pompeii, you know. Had a lot of cool statues, people like frozen in time. Anyway, if it happens, there's nothing we can do about it. But that's the essence, or shall we say, the potential of geothermal energy. So this is Jonathan Bowe signing off for now. Stay tuned for more in topic 6 next week, the Ring of Fire.